Let's talk about the planet that's been hiding in plain sight this whole time, right next door to our sun. It's the fastest world in the solar system, zipping around the sun in just 88 days. The ancients, they named it for the swift messenger of the gods, but for us, it's turned out to be one of the most mysterious, most paradoxical places we've ever studied. So let's dive in and explore this planet of paradoxes.
Okay, so first things first, we really need to get a handle on why this little planet has captivated us for literally thousands of years, and why, for most of that time, getting a decent look at it has been almost impossible. So, meet Mercury. Sure, it doesn't have the gorgeous rings of Saturn or the epic storms of Jupiter, but this little, cratered world is one of the solar system's true unsung heroes. It's a planet of wild extremes and fascinating contradictions that really makes us rethink how planets form and change over time.
And its name, it fits perfectly. The ancient Greeks called it Hermes, their winged messenger god. The Romans, they followed suit with Mercurius. Why? Well, because it's the fastest planet moving across our sky. That super quick 88-day year looked to them like some kind of divine messenger just racing across the heavens.
But here's the catch with all that speed. Mercury never really wanders far from the sun in our sky, and that means for us it's almost always lost in the sun's blinding glare. It only pops out for a really brief window during twilight, right after sunset or just before sunrise. It's a super elusive target, which is exactly why it's kept so many of its secrets for so long.
So what do we find when we finally manage to catch a glimpse of this speedy little world? We find a place that seems to just break all the rules, a true planet of paradoxes. Okay, so picture this. On the side of Mercury facing the sun, it is absolutely scorching. We're talking 800 degrees Fahrenheit. That's 430 Celsius. Just to give you some perspective, that's hot enough to melt lead. You might think, well, duh, it's the closest planet to the sun.
But then you flip over to the night side, and the temperature just plummets to a mind-numbing minus 290 Fahrenheit or minus 180 Celsius. That is a massive temperature swing, over 1,000 degrees Fahrenheit, and it all happens because Mercury has pretty much no atmosphere to trap the sun's heat and spread it around. But if you think that's strange, get ready for its calendar. This is just wild. 1 year on Mercury, so one full trip around the sun, takes just 88 Earth days. But a single solar day, the time from one sunrise to the next, takes 176 Earth days. Yep, you heard that right. A day on Mercury is literally twice as long as its entire year.
All right, those extremes are super fascinating, but they're really just clues pointing to an even deeper, even bigger puzzle. The central mystery of Mercury, the one that scientists have been banging their heads against for decades, lies deep, deep beneath its surface.
Just take a look at its insides. Unlike any other rocky planet in our solar system, Mercury has this gigantic metallic core. It makes up about 85% of the planet's entire radius. Its rocky mantle and crust are just this thin little shell wrapped around an enormous iron heart. This makes Mercury the second densest planet in the solar system, right after Earth, which is just bizarre for such a small world.
This quote from Astronomy magazine really nails it. How did this happen? Why is Mercury so incredibly iron-rich compared to its neighbors, Venus, Earth, and Mars? Scientists are pretty sure the answer is buried somewhere in its really violent past. So, they've come up with 3 main theories. Think of them as the top suspects. One idea is that a massive planet-shattering collision early in its life just blasted away most of its original rocky mantle, leaving that dense core behind. Another idea suggests the intense heat from the really young sun just boiled away its outer layers. And a third theory proposes that forces in the early solar system sorted materials by density, kind of pulling all the heavy iron stuff inward.
Okay, but how on earth could we test these ideas, or even figure out what that core is made of from millions of miles away? Well, the answer is just it's genius. It doesn't involve landing on the planet, but instead very carefully and precisely watching how it spins.
So first, you have to understand Mercury's unique little dance. It's locked in what we call a 3-to-2 spin-orbit resonance. What that means is, for every 2 trips it makes around the sun, it spins on its axis exactly 3 times. This really stable, predictable rhythm, that's the key.
Back in the 1970s, a scientist named Stanton Peele had this absolutely brilliant insight. He realized that if Mercury's core was liquid, it would affect the planet's spin in a very specific, measurable way. He basically figured out we could X-ray the planet's interior just by watching how it turns.
The effect he was looking for is called libration. You see, as Mercury orbits, the sun's gravity is constantly tugging on it, and this causes its rotation speed to minutely speed up and slow down. It's this tiny, predictable wobble. And the size of that wobble, Peale predicted, would tell us exactly what's inside.
Here's the absolute perfect analogy. Imagine you spin a raw egg and a hard-boiled egg on a countertop. The liquid yolk inside the raw egg sloshes around, it's disconnected from the shell, and it makes the whole thing wobble in a very particular way. The solid, hard-boiled egg, it just spins as one solid piece. Paley realized Mercury would behave just like one of those eggs.
So, scientists got to work. Using these incredibly powerful Earth-based radar systems and data from the Messenger spacecraft, they made unbelievably precise measurements. First, they measured Mercury's axial tilt, its obliquity. Now, to give you some context, a single degree in the sky is split into 60 arc minutes. They found Mercury's tilt was a stable 2.04 arc minutes. That's an incredibly tiny angle.
But then they measured the wobble, the libration. An arc minute is split into 60 arc seconds. So now we're talking about an even smaller slice of the sky. They measured the wobble at 38.7 arc seconds. It's an astonishingly small angle to measure from so far away, a true testament to modern astronomy. And that tiny number, it held a giant secret.
And here it is, the big reveal. That tiny wobble was double the size you'd expect if Mercury were a solid, hard-boiled planet. There was only one way to explain it. The planet's outer mantle had to be sloshing around a liquid core, just like the shell of that raw egg. The wobble proved it. Mercury has a molten, liquid outer core.
That discovery was a massive leap forward. I mean, a huge piece of the puzzle solved right there. But you know how it goes in science. Answering one big question just opens up a dozen new ones. The investigation is far, far from over. So we now know there's a liquid core, but we still don't know for sure which of those violent origin stories is the right one. We've also got strong evidence for water ice, actual ice, tucked away in craters at the poles that are permanently in shadow. How is that even possible on such a hot planet? And what in the world is generating Mercury's weak but definitely present magnetic field?
You know, Mercury is a survivor. It's a tiny world that somehow endured a chaotic, violent birth to become this bizarre planet of fire and ice, with a crazy calendar and a giant iron heart. It's a constant reminder that even our closest neighbors can still hold the most profound mysteries. Which just makes you wonder, what other secrets are still hiding out there right in the glare of our own sun?